This is going to be a little bit of a different style video in the sense that I'm not going over an example problem. It's hard to pick one particular trig identity proof and say, now do this for all the other ones, right? Because there's so many different ways to prove something in trigonometry. But there are some very useful steps. And once you get familiar using all these steps, the proofs tend to just sort of fall into place. But it does take practice. So I have here 8 steps. Okay, I'm going to go through and explain these and generally how they work. And this would be very, very good for you to think about, not in terms of a recipe list that you have to follow number 1 through number 8 in that order. Just in terms of these are your useful tools. These are your ways to solve trig identity proofs. The only exception to that statement is number 1 right here. Okay, this one, that is a hard rule. When you're playing with a trig proof, you can mess with both sides if you want, but that's not a solution. To actually solve a trig proof, you change one side and one side only until it matches the other side. And I would say pick the ugly side. If you don't know which side to make your changes to, whatever side looks more complicated, that's what you should do. Okay, now let's move on into the generally good idea strategies. None of these are things you have to do, but oftentimes they help quite a bit. Number 2, if you see any tangent functions, get those out of there. Turn them into sine over cosine. And likewise, with cotangent, if you see any cotangent functions, turn that into cosine over sine. These are the quotient identities. If you see secant functions, okay, secant turns into 1 over cosine, cosecant turns into 1 over sine by the reciprocal properties. And oftentimes, that will lead you into compound fractions. And it might feel like that's not a great way to go, but eventually, it's helpful. If you have a compound fraction like this, 1 over sine, and I'll just use theta, 1 over sine theta divided by, I don't know, cosine theta minus 1 over cosine theta. Okay, it's ugly, right? There's fractions within your fraction. You have to know how to deal with those fractions by clearing the denominators. And in this particular example, I know I have to multiply by a cosine theta in order to clear the denominators on the bottom, and a sine theta to clear the denominators on the top. But I have to have the equal functions on top and bottom of this fraction. So I need a cosine on top and a sine on bottom. And look what happens. If I multiply by this, I get cosine theta on top, and on bottom, I get cosine squared times sine minus sine. Okay, I'm using shorthand here. There should probably be some thetas in there just to keep everything correct. This is cosine squared of theta times sine of theta minus sine of theta. And maybe that's going to be easier for you to solve in some way. Okay, maybe that's going to get you where you need to go. But the important thing is getting rid of the compound fractions. Okay, next up, if you see common denominators, add them together, right? If I've got 1 over sine minus cosine squared over sine, okay, I'll put in the thetas. What is that really equal to? Well, it's just one big fraction over sine of theta. And on the top, you have 1 minus cosine squared of theta. And I think if you remember the Pythagorean identity, you might recognize 1 minus cosine squared as something important. There are ways to simplify this, but those simplifications only happen when you combine fractions. Okay, next up, number 6. Sometimes it's helpful to factor. Okay, if I give you something like, I don't know, 1 minus cosine squared of theta. Okay, and maybe you're not getting anywhere in the problem because you've got 1 minus cosine squared on top divided by 1 plus cosine, and you want to simplify this. Well, think about it this way: the top could be turned into 1 minus cosine theta times 1 plus cosine theta. Okay, that's a difference of squares. On the bottom, you still have that 1 plus cosine of theta. And now look, now we can do something we couldn't do before. You can strike out one of those common factors on top and bottom. And it would simplify to just 1 minus cosine theta, which is a lot nicer than what we started on the left. So sometimes factoring comes in handy. Differences of squares is very common. GCFs, greatest common factors, also comes up from time to time. So keep those old factoring techniques in mind. And I also want you guys to look for conjugates related to the Pythagorean identity. If you remember what a conjugate is, conjugate is, let's say I have something like this, and I want to simplify that. Well, the conjugate of the denominator would be 1 plus sine theta. So what do I mean when I say look for conjugates related to Pythagoreans? I know 1 minus sine squared and 1 minus cosine squared are special things by the Santa Claus identity. So the way to get there is to multiply this by a conjugate. 1 plus sine theta on top and 1 plus sine theta on bottom. Well, that difference of squares on the bottom produces this. It's going to make, well, the top doesn't go anywhere. That's just cosine theta times 1 plus sine theta. Okay, that is what it is. But on the bottom, this is now 1 minus sine squared theta. Okay, similar to that last example with factor by the difference of squares. So 1 minus sine squared theta, maybe I turn that into cosine squared theta. Okay, and if this is cosine squared theta, I see there's something I could simplify on the top and bottom now, a factor of cosine. And maybe that's helpful for whatever proof I'm working on. So conjugates are a useful thing to remember. Okay, they come up a lot, especially related to differences of squares factoring. And then this last tip right here is not terribly important. This is really a sometimes thing. If you have multi-angles, and we may not have gotten into these yet, but if you have the sine of 2 theta, okay, wouldn't it be nice to just call that this instead, 2 sine theta cosine theta? Remember that multi-angle identity? Or if you have, let's say you're dealing with something else. In your problem, you're dealing with sine of phi plus beta. Okay, maybe it's hard to work with in that form, but it might be easier if you had sine theta cos beta plus cos theta sine beta. Now, if this is complete Greek to you, that's a joke, guys, it's Greek letters. If it's just nonsense, maybe we haven't learned the multi-angle identities and summation identities yet in class. Okay, we'll get to these. For the most part, this stuff is not generally stuff that we'll see in proofs, only some of the more advanced proofs. And generally, what you're doing is factoring, conjugates, Pythagorean identities, reciprocal identities, quotient identities, and basic trigonometric algebra. Those are your go-to techniques.